So let's see exponential integrating x raised to the power n exponential x with respect to x. The question still remains, what is our u and what is our dv? So this is arithmetic and this is exponential. So considering like x as we have been doing, we realize that this a will be our u and the exponential will be our v. So u is will be x raised to the power n, and our dv dx or dv is x exponential x dx. So in this case, we will have to evaluate the u, and the u dx in this case is nx raised to the power n minus 1, and therefore the u will be nx raised to the power n minus 1 multiplied by dx. Now in the case of dv is equals to exponential x with respect to x, therefore our v will be equals to integral of exponential x with respect to x, and integrating exponential x, we will have exponential x. Therefore, let's apply integration by parts formula that says integral of u dv is equal to uv minus integral of v du. Therefore, integral of exponential n integral of x raised to the power n exponential x dx is equals to u. Our u is x raised to the power n, and our v, which is exponential x, minus integral of our v. Our v is x raised to the power x, and our du is nx n minus 1 dx. Now this will be equal to exponential n x raised to the power n exponential x. N is a constant which can be brought outside, and we have x raised to the power n minus 1 exponential x dx. Now the integral on the far right is seen to be as the form is seen to be of the same form as the integral on the left hand side, comparing x raised to the power n exponential x dx. So this is similar to this, except that n has been replaced with n minus 1. So therefore, if we say that, let's represent in to be equals to integral of x raised to the power n exponential x dx. Therefore, in minus 1 is equals to integral of x n minus 1 exponential x dx. So if we make our substitution using in, we can see now that this becomes in is equals to x raised to the power n exponential x minus n in minus 1. Now this formula here is called the reduction formula for integral of x raised to the power n, reduction formula for x raised to the power n exponential x dx. Now let's take an example. We are given integral of x squared exponential x to be integrated with respect to x. Now recall that the reduction formula of x raised to the power n exponential x dx is given as in, which is the same thing as x raised to the power n exponential x minus n in minus 1. So if we compare what we have here to this, we will realize that our n is equal to what? 2. Therefore, we have that our integral of x squared exponential x dx is equal to I2, which is equals to x raised to power 2 exponential x minus 2. Okay, wherever we see x, n, we substitute 2 into I substitute 2 minus 1. And 2 minus 1 is the same thing as what? 1. So we have reduced the weight of the problem to just evaluating I2. Now, in the expression of I2, we can see that there is I1 present. So we have to find an expression for I1. Following the formula that In is equals to x raised to power n exponential x minus n in minus 1, then I1, that means we are saying that n is equals to 1. Wherever we see n, we substitute 1. Will give us x raised to power 1 exponential x minus 1 I1 minus 1. Therefore, I1 is equals to x exponential x minus I0. In I2, we had an expression for I1, and we have been able to evaluate, deduce the formula for I1. And in the formula for I1, we can see that I0 is present. How then do we evaluate I0? Let's follow this one again. And when n is equals to 0, we have that I0 is equal to exponential 0 x raised to power 0 exponential x, okay, minus 0 I0 minus 1. So this returns to 0, and our I0 will be equals to x raised to power 0 exponential x, and which is the same thing as 1 multiplied by exponential x. So our I0 is equals to exponential x. Now, because there will be a constant of integration, we say that I0 is equal to exponential x plus c, but which that can be neglected for now. So we have evaluated I0. We will now substitute the value of I0 into I1, and we substitute the value of I1 into I2. So let's rewrite the expressions for I0, which is exponential x, I1. The expression for I1 is x exponential x minus I0, and the expression for I2, which is the question itself, is x squared exponential x minus 2I1. So let us evaluate I1 now. I1 is equals to x exponential x minus I0, and I0 is what? Exponential x. So let us substitute I1 into this, and our I2 will become x squared exponential x minus 2 into I1, and I1 is x exponential x minus exponential x, and this will give us x squared exponential x minus 2x exponential x plus 2 exponential x. So factorizing with exponential x now, remember that we are going to add plus c as the constant of integration. So we have that this factorized with exponential x, we have x squared minus 2x plus 2 plus c. And we recall that I2 in the question itself is integral of x squared exponential x dx. So therefore, the answer to the question we say is integral of x squared exponential x dx will be equals to this.